one side of the cover sheet, and it screwed everything up. I said that yesterday. Yeah, you don't listen to me. Okay, so your whole life, you've measured angles in what? Degrees.
So sorry for the late interruption after morning announcements, but if you are parked in the front loop, we're asking that you move your vehicle because there is no parking in the front loop. Thank you.
Okay. How many degrees are in a circle? 360. Look, see, we taught you so well. Hey, does this look more green? A little bit? Kind of, sort of? I'm just trying to get, like, money out of what I spend on pens. I just want you guys all to lie to me and tell me that it looks green. Okay, so we know that in a circle, and the reason why I'm talking about a circle is that we're familiar with it, and guess what we're learning about? We're going to be learning about the unit circle, okay? So here's the thing. We're moving into a world of radians. Now, it's a different unit of measure for measuring angles. So this is a new unit of measure. Unit of measure for angles. So your whole life, yes, this is kind of wrote on the back side of the page. Your whole life we've been dealing with degrees, and today we're going to talk about radians for the very first time. Good news about radians is they have no symbol. Okay? So it has no symbol. No. Isn't that nice? Sanders like, yes, I don't have to remember anything. So degrees, that indicated that it was a degree. In radians, you just leave it. It's a number. Don't put any symbol by it. You can write the word radians if you want beside it, but it's not required. It's implied that if you say theta is equal to 2, I know that you're talking about 2 radians. So you know the crazy teachers who kept saying, like, you've got to put your units in measure, you've got to put your units in measure. Well, 2 radians is significantly different than 2 degrees, right? Like, when you think about it, if a whole circle is 360, and that's a lot of slices of that pie, right? If I have to cut that pie up, they're little tiny things. So if I start here and I go all the way around, you guys would agree that's 360 degrees. In radians, it has a measurement of 2 pi. So like, that's great, lady. I don't know what you're talking about. What is pi? Give me the numerical value for pi. 3.14. We'll just stop there. So times that by 2 and 28, right? So this now is broken down into 6.28 slices. Those slices are significantly bigger. Does that make sense? So which angle measure is bigger? It's definitely, 1 radian is definitely significantly bigger than a degree. Does that make sense? You guys are like, I don't know. People at home, I hope you're nodding. Okay. All right. So we're going to go through some definitions of measuring angles, and you're like, Skyen, I know all these already. Oh, hang on. Somebody's talking to me in the chat. So excited. So excited. I got too much stuff open.
You bet it says hi.
Probably, or that they are nodding. One of the two. Okay, chat. Open up. Look at that. Oh, thanks, Cam. We're all like really excited to see what the person says, and Cam just gave us all the digits of pi. Not all of them, because obviously. Okay. Okay, so we're going to go through some definitions. We're going to do some pretty pictures to go with it. And I think the pictures kind of solidify the understanding of it. So the initial arm. Okay, very fancy definition. It's a position where we start angling where we start measuring the angle from. Got my words mixed up. And this happens on the positive x axis. Everybody good with that? So now what we're doing is I'm taking it and I'm snapping our angles. Like, I don't know if you did this in grade 8 or whatever. You guys learned how to use protractors and your teacher gave you like slices of pies that you had to learn how to use your protractor to measure. Well, now I'm taking that angle and I'm snapping it to a coordinate plane. Okay? So when we're talking about these, our vertices, so the sharp point's going to always be at the origin. Well, I guess I could draw it in here. This will be good. So pointy part here, and I'm going to get a different color. I know you're excited. So this right here would be my initial arm. So we always measure, and where are we going? So let's say it's right here. We know that this angle is what we're looking for, right? So this baseline here on the positive x-axis is my initial arm. It's where you start your angle from. Your vertice or your pointy part is always going to sit at the origin. It's not going to slide over. You're not going to be at -2. It's always going to be fixed on the origin. Like I've put a pin in it, and then we're going to rotate that terminal arm. That's the other one. So this is where you're jumping ahead of myself, but this is where your terminal arm is where the angle ends. And where the angle ends is where the angle ends. So again, if I were to draw this in, my vertice is there, my initial arm is here. Maybe this time I'll draw a different one. So this would be my terminal arm. And my theta, my angle measurement, would be from the initial arm to the terminal arm, right? So initial is where you start, terminal is where you end. Okay, so what would you say, estimating wise, that angle would be in my second picture here? There's something you definitely know about it. If you were to estimate, if I were to ask you to estimate on my terrible drawing, what would you estimate?
Like 120?
120, I like it.
110.
Okay, there's 110s, 115s. Okay, so what did you all know when you were making your estimation?
The 90 degree.
90 degree was right there, and we went beyond it, right? So there were some things that you can make an educated guess about. All right. So that's exciting. There's your terminal arms. Okay, positive angles are measured counterclockwise. Okay, and the symbol for that is CCW. Just in case you ever see that, CCW means counterclockwise. It doesn't matter. They're just, it's like an informal kind of like shorthand of, just so that if you see it or I write it, that's what it means. So you saw me there. We just said, you guys all gave me that estimation of 110, 115, 120. You guys said that was positive, right? Which is awesome. Here's the thing is, okay, so I guess I gotta draw a picture with it. I love that I can switch colors and it actually looks like I'm switching colors. I'm going to drop that one right here. So a positive angle would go in a counterclockwise direction. Okay? What would you guys say that degree, that estimated angle is? Now it's just gotten... Sure. So we're making a prediction that theta is approximately... And you guys are familiar with the approximate symbol. It's a straight line and then a wavy line on top of it. You guys are like, sure. We're saying that's approximately 290 degrees, right? Okay, good. Because you knew that this is 90, this is 180, that's 270, and I went beyond 270. So you guys are really familiar with like these basic things in degrees, but we're gonna change your life. Okay, negative angles are measured, anybody want to guess? clockwise direction. Okay, so some new things that are happening in your world. New things that are happening in your world are, all of a sudden, we're dealing with negative angles.
Why am I remembering that? Because if you get the positive angle, you get the negative angle.
Okay, so what you just talked about was a coterminal angle is what we call them. I know, crazy, eh? It's wild. So exciting. So Zander made the point that what's the point in measuring a negative angle? Because if I have a positive angle, I can figure out what my negative angle is. So I'm going to try to draw this again. Okay, so you guys would have said that this is 290, right? A positive 290. So then a negative angle, oh geez Louise, see? I got cocky. Now I'm going for a third color and we know it's all just going to look black. So this angle here is going to be a negative angle, and what is the measurement of it? What kind of 70? Right, so it's going to be a negative 70 degrees. So what you just discovered was if we measure this way, it's negative 70, and you end in the exact same place as a positive 290. So we refer to those as coterminal angles because you still end in the same place, but you got two different ways of getting there.
We never used to write it in degrees, like in our class, like grade 11.
No, we did no negatives in grade 11. Did we? No, we didn't do that. I'm looking at here, I'm like, we didn't do this, did we? No. Okay, so I'm taking a really long time to do definitions, and I just like to talk. I'm sorry. I feel comfortable here. Supplementary angles. What do supplementary angles add up to? 180. Two angles that add to 180 degrees. Complementary angles are two angles that add to what?
90.
I forgot a word. I always remember it as a compliment is nice, but taking me to supper is better. Right? Compliment is 90. Something better than that would be supper, which is more, so that's 180. That's how I always remember it. I don't know where I picked that up, but just FYI, that's compliment is nice, supper is more, supper is better. Obtuse angles, you guys know what this is?
Isn't it like past 90?
Okay.
90 plus theta?
So theta has to be greater than 90. Ooh, greater than 90, no equal sign there. But less than
180.
180. How do you guys feel about that notation? We good with it? If you ever struggle with this notation, cover up one side and read what that says. Theta is less than 90, and then cover up this side. But theta is greater than 190, theta is less than 180. So if you ever struggle with this, just cover up a side, read what it says, really take a moment to figure that out, and then go from there. So acute angles are going to be,
0 to 9.
theta has to be,
0 to 9.
so less than 90, but greater than 0? Or would that be an acute negative angle? Oh, so maybe this, oh, sorry, crossed out my theta and I didn't mean to. So maybe theta just needs to be less than 90. Kind of crazy, eh? Now that I've added negatives, it's a whole new world.
Could you just put, and also put negative 90?
Ooh, that's a good one. Okay, I like that. So has to be greater than negative 90, but less than positive 90. But then that would give us the potential for, no, I like that. I'm good with that. Okay,
So it can't be minus 180, like for acute angle?
it could be, but it's just, it has to be greater than 90. That's the most important thing. And we can't add that other piece in here. We'd have to make another statement completely about the negative piece. And we don't have to do that. It's just kind of getting your mind around how these things look. Most important thing is obtuse angles are somewhere in that second quadrant, and acute angles are in the first quadrant, right? Assuming we're talking positive angles. Ooh, sorry, I did those backwards. So that's that one, and this one has to be over here, right? If we're talking positive angles only. Because they're like, there's so many new things, and that was only page 1. Okay, I gotta pick it up if I wanna get through this. Are we good if I flip? All right, we kind of discussed this already. What's a radian? A radian is a unit of measure used for angles, no unit symbol. That's really important. Okay, all right. Now we're getting into the unit circle. So here's the unit circle connection. You guys know that if my initial arm starts here, and I go all the way to here, how far have I traveled? 90 degrees. That's exciting. So I'm going to tell you that the radian measurement that goes with 90 is pi over 2. All right, so if you were to hedge a bet, well, it's already on there. If this is pi over 2, if this is half a pi, what's this measurement? Half a pi and another half a pi gives me pi. So 180 is pi. All right, so we're gonna keep going around. So I got a pi plus another half a pi. 3/4 pi. Oh, 270 isn't even on this list. Let's add that in, 270. Is it 3/4?
1.5.
1.5, so give that to me as an improper fraction.
3/2 of pi.
3/2, right? So if you guys are saying that this is a half, this is a half, and this is a half, how many halves do I have? 3. Okay, so I'm going to go one more half. How many halves do I have? 4. So 4 halves. So 4 pi over 2, or 2 pi. We kind of already talked about that, right? So that shouldn't be shocking. All right, okay. So let's do some math. Math and fractions. It's a tough Friday, okay? And the reason why I'm going to make you do it fraction-wise, because I can tell you what it is, but I think it'll make more sense. You guys said that this 90 degrees, well, I told you, that it was half a pi. You guys agree with me? All right, so let's go into 30. 30 is probably the easier one to start with. So if we know that this measurement here is 90 degrees, if I'm doing 30 degrees,
1/3 of a half.
1/3 of a half, I like it. So what is that? So pi over 2 divided by 3, right? Because we would cut our 90 degrees in 3 sections, so we'd be dividing by 3. So pi over 2 multiplied by 1/3, so this is going to be pi by 6. All right. So, geez, like I'm going to switch. So if this is pi by 6, now let's go to 60. So if this is 30, this one up here would be another 30, right?
So pi by 2/3.
Okay, so this is pi by 6, this is pi by 6,
Pi by
2 pi by 6, because how many pi by 6s do I have? 2. So that would be 2 pi by 6, but am I going to leave it like that? Pi by 3.
Wait, how did you get that?
Just,
I missed it.
Okay, so we said that this is 90, right? And when we wanted to get 30, we just divided the 90 by 3. So we took the pi by 2 and divided it by 3 and got pi by 6, right? How many pi by 6s, how many 30 degrees are in 60 degrees? 2. So pi by 6, because you would say 30 plus 30 gives me my 60 degrees. So pi by 6 plus pi by 6 gives me the 2 pi by 6, and we just reduce that to pi over 3. Okay, all right, I think. Okay, 45, half of 90, right? So if, I'm just gonna draw a new unit circle here. Oh, it's not as pretty as the one that the computer did for me, but we'll go with it. So we know that this is 90, this whole thing is 90 here. What's 45? It's half, so it's 90 divided by 2, so 45 would be right there. So if we know 90 is pi by 2, and we're going to divide it by 2, what's 45?
Pi by 4.
Pi by 4. This has been a lot. This has been a lot. All right. Let's talk about 1 degree.
10, 1 over 10.
What would it be, sorry?
5 by 2 over 10, like 5 by 2 divided by 10.
Why 10?
Just 1 degree, so you have 90 degrees, right?
Right? Okay, so we would have 90.
We divide 90, yeah.
Okay, so if we know this is 90 and we want 1 degree, that's my 1 degree sign, everybody. It's very, very small. So we want 1 degree. What are we dividing the 90 by?
90, yeah.
We're dividing the 90 by 90. 90 degrees divided by 90 is going to give me 1 degree, right? Everybody agree with that? So now we're going to do it. Notice the degree symbol is only ever on the top one. So now we're going to have, what's 90? 90 is pi by 2, and we're dividing it by 90. So it's going to be pi by 180. So I know I made you do a lot of fraction work, but I think it helps you see the connection between the 90 degrees and all the other pieces. Okay, I'm going to tell you that, because I like to tell you these things, this one, this one, this one, this one, this one, this one, and that one are what you're going to memorize. And then you're going to memorize some coordinate pairs to go with them. Okay? Oh yeah, and there's a few more, but we'll get to those later. But if you can do the first quadrant, then you can do all the other quadrants by just like mental math or figuring it out, like understanding. Okay, this is the not exciting part. This is my least exciting part. I don't know if we even need to do this, but let's do our calculator values. So I'm going to do 2 pi first, so 2 times pi, and we're going to get some crazy irrational number. So 6.28.
what's that unit value? Like if you have to turn radians back into degrees?
Oh, we've got a formula. That's what we're doing today.
Okay.
Yeah, it's really easy. It's really, really easy. Going back and forth.
Radians to degrees to degrees.
We're going to go degrees to radians, and we're going to go radians to degrees. Okay, so I need you to know that this is an exact value. This is approximate. And that shouldn't be a shock to anybody, because we're dealing with pi, and like Cam put in the chat, it's irrational. So it's going to go on forever. So there's some sort of editing that we have to do there. Pi obviously is 3.14. Pi divided by 2. So, I mean, if you didn't have a calculator, you really could just figure this out Like if you know pi is 3.14, you can just start dividing by 2, dividing by 4, get the old school long division out if I had your calculators from you. The point of this is not to traumatize you. Well, kind of. But the point of this is just to show you that the relationship of radians in relation to where you are on that unit circle. Because I think if you can do that, then you're cooking with fire. If you understand this part of it, I think that you'll be able to rationalize how the rest of it works. Oh, I forgot my division symbol. And then I have 3 times pi divided by 2. I did all 2 decimals and then I got crazy. So all I'm trying to say is, and I showed this to you before, is that if 360, we know that our pi is sliced in these little tiny degrees, right? All of a sudden, if I do that in radians, it's like 6 1/3, right? So my slices are much, much bigger. So you just have to remember, one of the questions that I like to ask is draw me a picture of approximately 3 radians. Draw me a picture of an angle measurement that's approximately 3 radians. Okay, all right, so let's do it. So if theta is equal to 3, if there's no unit of measure stated, what do we know it is? It's radians. Okay. We know our initial arm is here. Where would 3 radians, where would the terminal arm be? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4?
Quadrant 3.
1, 4, 2.
It's in 2. How do I know that?
Magic.
Yes. What's 90 degrees?
Pi over 2.
Pi over 2. What's 180 degrees? Pi. 3 pi over 2 and 2 pi. What is the approximate value of pi?
Oh.
Right? So pi is approximately 3.14. So that's the radian measure of 180 degrees. Right? This is the radian measure. So if I asked you for an angle of 3 radians, it's going to be really, really close. Really, really close to that negative x-axis. Does that make sense to everybody? And so now I'm asking you to like change your mind, and you guys have always worked in degrees, but remember that 2 pi is 6.28. So 3 is less than half. And less than half of a circle is in quadrant 2. That's a favorite question of mine to ask. Hint, hint, nudge, nudge. If I asked you to write an angle measurement of 4 radians, where would you be? Quadrant 1, 2, or 3?
It should be 3.
3.
3.
2
Right? Because this one has 4.71 approximately, right? So 4, this is 3.1, this is 4.7, it's going to be somewhere in quadrant 3. Make sense?
You asked us like for radians. Where is the on this? You just approximately draw.
Approximately, but I will tell you, I would expect if I said 3, this line to be really close to here. If you did this, I would mark that wrong. Because that's, like, you should know that 3 is really close to 3.14, so I'd expect it not to be halfway through. And again, these are the minute details. I'd expect it to be closer to that negative x-axis.
Or 4, it should be closer to, like, not that close, but.
Not that close, not as close as we put this one, but 4 would be, I don't know, maybe here. I'd want it to be closer to the negative y-axis than the negative x-axis. And again, it's all approximate, right? So it's not just good enough knowing where it is, but approximately. So if I know, like again, if you know pi is 3.14, which we've beat into your head since you were small children, and we even have a day to celebrate it, you should be able to know where all, like what the calculator value is for all those other places, right? You can take half of pi, you can divide it by 2. Okay, all right, I need to stop with the chit-chattering. We got way too much to do. Ha! Somebody really needs to, like, scallion, just get to the meat and potatoes of it. Okay, so these are nowhere in your notes. These are nowhere on your formula sheets. They're not going to be in your notes. Please let them be in your notes, because if I don't do them in your notes, then you're going to be. So, degrees to radians. If I have degrees and I want to get to radians, the easiest way to do it is to multiply by pi over 180. Anybody remember where that was? What's each degree worth? Pi by 180. So if I have 45 degrees, I'm going to times it by whatever the value of each degree is. Does that make sense to everybody? So 1 degree is pi by 180, so you are going to multiply by pi by 180. Okay, so we're going to convert to degrees, because it has the degree symbol, to radians. 2 times pi by 180 gives me 2 pi by 180. Is that how I'm going to leave it? No, because again, it's got to be in simplest form. So we have to convert it to pi. Oh, don't put the degree symbol. I just reduced the fraction. That's all I did.
Sorry, I saw the degrees.
No, and I just got excited. So really super easy. 25, oh geez Louise, 25 by pi over 180. Can I reduce that?
Yeah.
Yeah?
By 5.
By 5. So 180 divided by 5? 36. So we're going to have 5 pi by 36. And we have 108 times pi over 180. Can I deal with that? Uh,
9?
9? Which one's 9?
Wait, no, I think I'm wrong. No.
I think you're right.
Yeah,
You can divide by 9.
180.
No.
Yeah.
Oh, and then I can keep going from here. If you can get it down to a more reasonable number, what I did was I took this and I divided it by 6, and I divided this one by 6, and I got 9 over 15. Although I reduced it, it's not in simplest form. What's the simplest form?
3 over 5.
3 pi over 5. Okay, I want to tell you that all of these are exact values because they are in relation to pi. The pi is in there. So when I take away your calculator, I'm going to be expecting everything in exact values. I don't expect you to convert like 3 times 3.14159 divide by 5. I expect you to leave the angle measurement as this. This is an angle. This is an angle. It doesn't look like it because it's different, but this is an angle measurement. All right, so if we want to go opposite, radians to degrees.
185.
So we're going to multiply by. Flip it. Now this is nowhere. This is nowhere, but what helps me remember, like, cause you're gonna be doing this on your first quiz next Wednesday, I remember that if I'm gonna end up with radians in their exact values, pi is always on top. So I know that my pi is on top when I'm multiplying, okay? I know that if I have radians, I already have a pi, so my pi is on the bottom because I'm gonna cancel them out. Okay, that's how I remember where the pi goes. You guys are like, I don't know what you're talking about. You'll get there. All right, so if we're gonna convert this, what do we know pi by 4 is? We just did it in our table of values. Pi by 4, 45 degrees. So we know the answer to this one, so we should be able to get it right, I hope. Okay, so we have pi over 4 times 180 by pi. The whole goal of this is if we're converting to degrees, we're not gonna have a pi symbol in there. So 180 divided by 4 gives me 45. What do I need with that 45? Degree symbol. Right, because it is, like there is a symbol. That's what it is, it's a symbol. 3 over 2 pi we know from our table. 270. So what I'm gonna do here, obviously my pi's cancel out, but I'm gonna go 2 goes into 180, 90, 3 times 90 is my 270. So I'm gonna get a little bit better of doing these quick tricks to help me have smaller numbers so that they're not so hard to deal with without a calculator. I think we do a disservice to you guys by kind of skimming over these strategies, and if you don't get them, don't worry about it, use your calculator, because you really do need those strategies now, right? I'm gonna take your calculator away from you. I just want you to be emotionally prepared. Okay. Well, that's ugly. If I give you this or something like this, it's going to be on a calculator portion. You will have your calculator with you, and you're just gonna do the math. Trust your math. So in my handy dandy calculator, I'm just gonna go 5.13 times 180 gives me that, divide by pi, and you should always be using the pi button in your calculator. You shouldn't be using 3.14, okay? You should be using the pi button. And so that's gonna be 293.93 degrees. We do not do sig figs. Xander is not gonna need to cry today. So really, the big thing, I'm probably gonna make you draw an angle on your quiz on Wednesday, because I'm a big fan of that question. I'm gonna make you do some conversions, okay? So you need to memorize how to go from degrees to radians and radians to degrees, which one you're multiplying by. Okay? All right, let's do some complementary angles. Complementary angles add up to 90 degrees, but let's put that into radians. What's 90 degrees as a radian measure? Pi over 2. No, complementary angles don't add up to 90. They do. Yep, they do. Complements are nice. Supper's better. Got it. Supplementary angles add up to 180, and that is pi. So all of a sudden, our whole world that we knew has just become much more complicated because we're adding this new layer. It's kind of like when you learn imperial for the first time, like things, trying to figure out what feet to miles to inches, what those conversions are. Like we've added a whole new layer of like just bad. Okay, so we're gonna find the supplement of 3 pi over 4. So we have 3 pi over 4 plus something equals pi over 2. I'm trying to find that question mark. So how would you do it, mathematically speaking?
Subtract.
You're going to subtract, right? So your unknown is going to be pi over 2 subtract 3 pi over 4. And if you ask me if you can use decimals, my heart's going to break a little bit. Yep.
What do you mean by like finding the supplement?
Find the supplement. Remember that a supplementary angle in our definitions was,
Less than 180.
no, supplementary.
Yeah, and ask some.
Two angles
That
that add
I was wondering.
up to 180. So if I need to find the supplement, oh, well that's not pi over 2, that's pi. So it's 2 angles, there's your first angle, there's your second angle, so angle 1.
Really counts about 5.
Okay, it's just pi because it's supplement, right? So we're adding up to 180, so it's just pi. So how am I going to do this? And if you try to say decimals, I'm going to light you on fire. I won't light you on fire. I talk a good talk, but...
I just want to put a little hole in the part.
Times 4 by.
Right, we need common denominators. Your rules for fractions don't ever change. These are mathematical truths. So this is going to be 4 pi over 4 minus 3 pi over 4. And that gives me
5 over 4.
pi over 4. Which I think you probably could have figured out just looking at that if I hadn't screwed it up. If I have 3 pi's over 4 and I need to get to 4 pi's over 4, what am I missing?
Yeah.
The other pi over 4, right? So some of these you'll be able to do pretty quickly. All right, so find the complement, maybe I should just write these things right above it, of 30 degrees expressed as radians. We can do it one of two ways. You can convert 30 degrees to radians, option 1, or do it all in relation to degrees and then convert your answer.
Probably the second answer would be easier, isn't it?
Whatever floats your boat. But if I gave you this question on a quiz, it's going to be a 1-mark question, and if you give me the answer in degrees, it will be wrong, even if your answer is correct, because I've asked for radians. Okay, so I'm going to suggest that you drop that into radians right away. So using your table, what is 30 degrees?
Pi over 6.
Pi over 6. All right, so we know that pi over 6 plus something has to give me pi over 2. And so we'll just do that subtract again. So pi over 2 minus pi over 6. Again, we need common denominators. So I'm going to times this by 3, that by 3. So 3 pi over 6, which is half a pi, right? And you don't need to show me this step. If you can just jump right to here, I'm cool with that.
2 pi over 6.
Right. So my answer is going to be 2 pi over 6. Am I going to leave it as 2 pi over 6?
And I can reduce it.
I'm going to reduce it.
So 1 pi over 3. Pi over 3.
So if you left me with this as an answer, this would be half a mark out of 1, because you didn't reduce it. That would give you the full 1 mark. Okay? Whew! Maybe I'd make that a 2-mark question. I don't think so. Find the complement. Okay, complement is nice. So that is a pi over 2. And you guys do this one. I'll do it over here. You guys do it over there.
Can you flip back to the last page for a second?
Of course. Sorry, this is the advanced class, flipping pages.
The one after that, though.
The one after it? That's the page we're on. That one?
Yeah.
That one?
Yeah, I was just looking for the notes there.
Okay. I don't know where you want me to be, but, okay, what did you guys get?
Pi over
Pi
6.
over 6.
You guys got a pi over 6?
Yeah.
Did you get a positive or negative?
Positive.
Positive. Positive.
Really?
Oh, no, I did.
Really?
Oh, it-
Yeah, you did.
Oh, you scared me.
But it can be negative, right?
No, it can't be, right? Because you're looking for the thing that adds up to, I mean, I guess you could add a negative on there. So that's the last one for that. I think that's the end of our notes for this one.
There's one.
There's one more page. Jeez Louise, I'm like, oh, easy lesson, no big deal, we're all good. Oh, coterminal angles. We talked about these already. Okay. Find a coterminal angle to add or subtract. To find the coterminal angle, either add or subtract. Does that make sense to everybody? Kind of, sort of? You guys are like, I don't know what you're talking about, lady. So we did that. We did that on our very first page, right? We knew that first angle was 290 in the positive. To get to that negative 70, we took 290 away from 360. So the reason why it's just in both, like for these ones, we're going to do positive coterminal angles, and they're going to be in degrees. Here we're going to do positive coterminal angles in radians, because these ones are in radians. So you're living in two worlds now, folks. You're living in the degree world or not. Okay, so we need to find a positive coterminal angle. So you guys would agree that 60 degrees is somewhere here. Yes, you guys would agree? All right, so a positive coterminal angle, any coterminal angle is going to have the same terminal arm. And we go in full rotations. All right, so if I want to end up back here, I'm going to add 360 to it. Because if I go around once, that's 360, and then I have to go another 60 to get to that terminal arm. So where am I? Yep. So 420, an angle measurement of 420 will have the same terminal arm as 60 degrees. Anybody want to give me another one? $780. What did I just do? I took 420 and I went around one full time. You guys know that a full rotation, when I refer to a full rotation, that's once around the circle. So if I start here and I want to end back there, I'm simply just adding 360 degrees. So we could all have different answers for coterminal angles because it didn't give us a restriction. So this is unlimited options. I have no idea why Xander would add 360 9 times when you can add it once and get the correct answer. You know what I mean? Like, you can add it 9 times and get the correct answer. You can add it once and get the correct answer. All it asked for was a positive coterminal angle. Okay? Everybody good? All right. Okay, 120. It's really easy, guys. Don't overthink it. So 120, and all you do is add one full rotation to it. That's a positive coterminal angle. That's going to end where 120 is. Now, I could add another 360 to it and get a new positive coterminal angle. I don't have to, though. 560. What are you going to do to it? Ah, that's totally an option. So, I mean, what we've been doing is adding 360. So let's do that one first. So that's going to be 2, and that's going to be 920, right? So that's a positive coterminal angle. But I think what Kira noticed was if I subtract 360 from this, I'm still going to have a positive angle measurement, and that's going to be at 200 degrees. So this one's right, and this one's right. Does that make sense to everybody? So it's the add subtract. You can do both. So because there was no restriction, we had unlimited possibilities for answers. And that's a pain in my butt because then I have to check. Yep.
Or we can subtract 360 from 129.
Right, because the question said positive coterminal. So my angles all have to be positive.
If it says negative, then we have to subtract.
Or if I say a coterminal angle, where I don't define whether it has to be positive or negative.
Okay, so we have to subtract then?
Or add, if I didn't define it, yeah. Okay, so find a positive coterminal angle. Ah, now it's giving me a restriction. So this is 1 rotation. It has to be between 0 to 360. So I called it 1 rotation because you can only go around the circle once. That's what that restriction is telling me. Restrictions are going to be your like worst enemy, best friend, I'm not sure, but you get it. Okay, so here's the thing. What's 1 full rotation? 2 pi, right? This has a denominator of 3. All right, so what I'm going to first do is I'm going to figure out what a full rotation is with a denominator of 3. I always do that. Makes sense to me, right? You guys are like, it makes no sense to me, Scallion. I don't know why you're doing that. Because I either have to add or subtract full rotations. And these are fractions now, so I got to have common denominators. So I just figure out off to the side somewhere that 2 pi is 6 pi over 3. All right, so if I went ahead and add 6 pi over 3, I end up at 20 pi over 3. Is that in that restriction? So this is wrong. This would give you a wrong answer because you're not within 6 pi over 3. So now what I got to do, if I can't add, what's the other thing I'm going to do? Subtract. And once you guys get this, you're going to be like, oh, this is so easy. Okay, 14 minus 6 is 8. Is that within the rotation of 6 pi over 3? No, so what do I got to do? Subtract again. Whew. Is 2 pi over 3 within this restriction? Yes, it's less than 6 pi over 3. So this is my answer. So I had to do it twice to get it within that unit circle. Are you packing up, Sander? We ain't done.
We still have 5 minutes.
We still have 5 minutes. I'm going to use all my 5 minutes. Okay, let's talk about 103 over 6. Okay, so off to the side I'm going to say, okay, 2 pi is equal to 12 pi over 6. I always do that. This is just kind of like my side note here, just to kind of remember what a rotation is with a denominator of 6. Okay, guys, this is going to take us forever. So 103 pi over 6 minus 12 pi over 6. Sweet goodness. That's going to take me forever. So where am I? Is that going to be 81? No. 91. 91 ooh, pi over 6. I got to get it down to 12 pi. I'm not going to do this one by one. I'm going to say, how many rotations do I got? So if this is 91 pi, so if I go 12 times 7, that's 84. So 7 full rotations is 84 pi over 6. All I did was take 7 times by 12 pi over 6 gives me the 84 pi over 6. Does that make sense what I just did there?
So you just get like 7?
Well, I knew that 9 would be too many, right? So I just picked 7. I knew 5 would be too little because that's only 60, right? So I'm just kind of hedged bets. And so now what I'm going to do is I'm going to take the full 7 rotations off there because I just have to go in full rotations. That's all I have to do. So 91 minus 84. 7 pi over 6. Is that less than 12 pi over 6?
Yes.
So this is good. Does that make sense? So that's why I do that little side note there to kind of like tell me where my focus is. And then you get lazy. I want to do 7 full rotations because I'm not going to keep subtracting. It's too long. You can do it. Minus 12 pi, minus 12 pi, minus 12 pi, minus 12. You can do that. There's nothing wrong with that. But it's about being efficient. Write an expression for all values that the coterminal, with the angle? Oh, okay, yeah, that makes sense. So these are general solutions. Okay, I think I'm going to leave it here for today. I'm going to hit pause on this and I'll pick it up in the next video because I want to talk a little bit about general solutions.